Thank you everyone for coming, and it's really great to have kind of opportunity to get a lot of these streaming SQL experts together. I'll probably just get started. Would have everyone kind of do a quick introduction about your background, your project, and also kind of how you related to streaming SQL. It's probably kind of 30 seconds to 60 seconds. So depending on how long you want to kind of use that a minute. You can maybe get started with Joe.
Oh, nice. Hi, everyone. This is Joe. I'm co-founder of TimePlus. I answer your question first because I'm working on two YouTube video podcasts, which is one is learning streaming SQL in 3 minutes. Every video is 3 minutes to tell some new story or new concept. The other one is streaming caffeine. So we essentially is a streaming database or streaming OLAP, combining the best part of Flink, and Kafka or Pulsar, and as well as ClickHouse in a single binary process. So the idea that is you can put any data in and you get both the batch processing and the streaming processing. We can get part to that later. Yeah.
Hey everyone, my name is Jerry. I've worked on stream processing for my whole career since grad school. Things I've worked on Apache Storm back in the day. Know some people here that worked on Apache Storm, Apache Heron, and then Pulsar, co-created Pulsar functions, Parcel SQL, worked on Pulsar a lot. Now I'm working at Databricks on Spark streaming, so that's what my team does. And lots of cool stuff and interesting innovations we're doing on Spark streaming. So yeah, it's a little bit about me.
Thank you. Hi everyone, my name is Hojjat. I am founder and CEO at DeltaStream. And DeltaStream is a serverless stream processing platform powered by Flink that combines both stream processing and streaming database in one unified platform. Before that, I was at Confluent and started a project called KCQL. Later, we called it KCQLDB. And one of the very, very early efforts to have streaming SQL on top of systems like Kafka.
The mic, yeah. Hello. Hi everyone, I'm Min Jun, and I'm the founder and CEO of RisingWave Labs. So RisingWave is a distributed SQL streaming database, and it's open source under Apache 2.0 license. And a lot of people, if you know me, will probably know that some people will say that you hate Flink, right? But actually, that's not the whole story, right? Well, because we think that Flink is like a burger shop, right? Well, but for us, it's more like selling sushi, right? Well, I cannot say that sushi is better than burger, right? So we're not claiming that sushi is just another new type of burger, right? Well, I will not say that. But we're quite different from Flink. We are actually all in streaming SQL. Probably that's one of the reasons that's why they invited me to a panel, right? We only do SQL, but SQL with UDF, SQL with Python UDF, SQL with Java UDF, but we do not really provide the programmable APIs like the Flink Java API or Flink Scala API. We do not do that. So yeah, that's what we're doing.
Hey, hello everyone. My name is Nin. I'm one of the founding members of Stream Native. And currently I'm driving the efforts at Stream Native to delivering all the computer-related products, including Pulsar functions, Pulsar IO connectors, and also the integration between Pulsar and the Flink and Pulsar and Spark. And in addition to that, we recently developed this new abstraction on top of Pulsar functions called PFSQL, which we want to ease our users' life in terms of dealing with some of the simple ETL jobs. So before that, I was working at Twitter and working on the Apache Heron project, which is a kind of streaming engine, a successor of Storm. That's basically my background. Thank you.
Cool. Thank you, everyone. I think all of you have a very interesting background. Some of them are coming from popular processing framework like Spark. I think Hojjat is the creator of KeySQL, and right now choosing Flink SQL as the kind of backend for extension to creating your own product. I think Jove and Injin has kind of starting a different approach to creating a different product. Is also kind of touching streaming SQL, but diving in deeper into that is probably, before diving deeper into that is, I would like to kind of get a little bit kind of opinion is what do you think about what is streaming SQL and how does it different from the traditional SQL? Maybe someone want to get started?
We are very good engineers, so we follow the order. Cool. What's next thing? Yeah. Again, so the idea of streaming SQL is to give you a new way to achieve real time and stateful in a different way, right? So you may know like Apache Pinot or Joy, they are really like good real-time database. But in order to get, say, what's my revenue for the past 1 minute, what's the total count, you have to keep scanning the data over and over again. Even they can get very high QPS or query per second, but still a lot of resources wasted to keep scanning the data, right? But the idea of streaming processor, which is very popular driven by Apache Flink and other projects, that is you can have a good processor to keep the state and figure out what's the change, and you don't have to rescan everything. And we, including Templars, Rising Wave, and many other vendors in this space, we try to push to the next level. That is, can we have a single SQL-based interface to query the data to understanding what's happening right now, what's in the past, and what's coming? Ideally in a single query, no matter it's subquery CTE or using combining with UDF, but that will be a really easy way to build your logic, maintain your logic, and without hiring a bunch of experienced engineers. Yeah, that's the idea.
Cool. So in my mind, like the difference really between traditional like SQL and streaming SQL is traditional SQL and databases, right? Those are more like point in time queries, right? You query the data, you get a result, and that's it, right? The query has a beginning and an end. For streaming SQL or continuous SQL in a sense, it's running forever, right? It may emit results, it may emit partial results, or may emit updates to those results, right? It's a continuous kind of processing query, and also one of the key things, just like Joe mentioned, is that it is incremental to some degree, right? And that, I think, is something that is a huge benefit over traditional SQL, that you can basically process a lot of data in an incremental fashion, which not only kind of has consequences on like fault tolerance, but also on cost. So that's a huge deal, especially for users that are at kind of the internet scale, and they have to process a lot of data, but they want to also like lower their cost.
I think I'm gonna just continue what Jerry said. I was gonna say that, but you kind of like started it. But I am totally on the same page. In short, just processing in the streaming SQL, I define it as a continuous queries, meaning that your queries are continuously running and data is going through the query. I remember in my ex-employer, we used to call it turning database inside out. In normal databases, you have data sitting there or data at rest, and queries come and go. As Jerry said, query starts, and a millisecond or 100 milliseconds later, you have the result, and that query is gone. You just come with new queries. In continuous query case, query is sitting there, and data goes through the query instead of the other way around, that data sits there and query is coming to the data. So I would define streaming SQL running continuous queries on top of data in motion. And these queries can be stateful, stateless. You can build persistence for the results and materialized views and those kind of stuff. I would categorize all of them as part of streaming SQL.
My definition of streaming SQL is probably quite similar to theirs, right? But well, one unique thing in our case is that we believe that people should use the streaming SQL in the same way as they use the batch SQL. So basically, they should not know what is streaming SQL. They should not know what is batch SQL. They should not know that. They should just know how I can do this and do that, right? Well, and whether I can. So think about if you have a dashboard, right? So people know these days, people probably write a SQL and plug into, let's say, your Grafana, your Metabase, right? And you run the SQL, right? And people are aware of the SQL. So in our case, what do they say? But the dashboard is kind of dynamic, right? But what do we say is that, look, you can write exactly the same SQL, but just change the database, change to our database, and then you can get a dynamic dashboard right? And you can always get a fresh result. That's our definition. But for the definitely, streaming SQL will have unique features like it has a window function, right? And it has time window function. It's not the SQL's window function; it's time window function. It also have the watermark, right? Where you have all kinds of the unique features. And definitely that's pretty important in stream processing, and we all bring into the SQL part, and we believe that it's a feature. But the whole idea is that okay, we don't really want people to differentiate. Okay, what is streaming SQL? They just treat this kind of thing as a feature.
Okay, so since I'm coming from a streaming engine background, so our understanding for streaming SQL is like it's yet another way to represent the tasks people want to do on top of the streaming data. So I think just as the Discord sharing in the keynote, we have like in the streaming world we have like different levels of engine, and the SQL is at the very high level and a very abstract way to allow people to express what they want to do on top of data. And since like it's streaming SQL, so definitely like the SQL is targeting the streaming data or the data in motion. And given this like nature of the data that is always like moving, so it has like some kind of unique characteristics, like it's never ending, it's kind of endless, always coming, and there will be some kind of order issues for the data. And those like intrinsic with the streaming data. So that's our understanding.
Thank you. I think that's a good kind of a combination of explanation was streaming SQL. I'm kind of going off a little bit kind of on the script. So I want to get the conversation a little bit heated here. I mean, obviously everyone know Confluent like announced they adopt Flink, and that is an acknowledgement, recognition of Flink is the de facto standard of stream processing. And that means Flink SQL will become a little bit on the standard of streaming SQL and to a certain extent. And I know probably the question will get started to Hojed is you are the creators of KSQL. And when you come out of Confluent, why you decide not to kind of build on KSQL and choose Flink SQL as the backend, and what is the advantage of Flink, and what kind of limitation do you see there?
Yeah. Actually, the decision was not based on the Flink SQL. I think Flink SQL itself, or using standard SQL for streaming, has a lot of shortcomings that I think I mean be disagreeing in that one with you. But the reasons that we chose Flink as our stream processing engine in Delta Stream was that if you go back to KSQL at Confluent, it was built on top of Kafka Streams, and it was tightly coupled to Kafka. We wanted an engine that would go beyond Kafka, meaning that if you want to run queries on Kinesis, if you want to run queries on Pulsar and other streaming systems, and just go beyond streaming systems, you would have that flexibility. That was one of the main reasons that we decided to use Flink instead of using Kafka Streams or just building something similar to KSQL. On the streaming SQL part, going back to what we mentioned, I think using standard SQL, I will give you two examples. Standard SQL, all of the relations that you have are tables. But in the streaming world, you have different types of streams. You have append-only streams. You have absurd streams that they have different semantics. And of course, you have, if you want to build something that would work for batch and streaming, you have also normal tables. If you use same primitive like table to define all of them, you can easily see that it can result in a lot of confusion. I have a table that represents a append-only stream. I have a table that represents a changelog stream, and I have a table that's just a data at rest table and setting in Postgres, for instance. And when you do joins, when you do other operations on these streams, those have different semantics. And as a user, you're going to have a difficult time, and it's going to be very confusing to kind of like remember which table was which type of semantic, which table. So actually, last year I had a talk on Flink Forward, as I mentioned earlier to you, that we were proposing some extension to what if we actually have a notion of new type of relation. The same way in normal databases, we have different types of relation. We have table, we have materialized view, we have view, and each of them mean different things. And we can have something like stream that would represent the append-only stream. Something like changelog that would represent a changelog stream. And by just seeing that, okay, this is a stream and this is a changelog, you can easily say that, okay, if I join a stream and changelog, this is going to be a temporal join. If I join a stream with a stream, I know that it's going to be, the result is going to be another stream and so forth. So based on that, in Delta Stream, actually, we added these extra or extensions to SQL. So the user would be easily understand, okay, I'm in a streaming world, and based on these definitions, I can easily predict or know that the behavior of this operation, this query that I have, what the behavior is going to be and what the result is going to be. And based on that, a little bit simplify the life of the user. Let's put it in this way.
Cool. Thank you. I think you mentioned about kind of materialized view. I'll probably touch base on that that topic later on. But I just want to get the heat continue. Is probably the question going to Jerry. Now you're working on a project at Databricks. It's called Project Lightspeed. That is all about kind of bring Spark structured streaming into next level. And how do you feel about the like streaming SQL as part of Spark, and what's the plan there?
So at Databricks, one of the, I think, key things that we focus on, right, and I think that's one of the reasons why, Databricks is popular, is kind of the user experience, right, and also the kind of ecosystem around not only Spark but also Databricks, right. So as we look into working on structured streaming and moving forward with that, that's one of the key things we work on, as well as Databricks also offers another product. Technically, you cannot do SQL on top of structured streaming or Spark streaming, right? You can use the API. It is a declarative API, but it is not SQL. So how Databricks offers streaming SQL is actually through another product we offer is called Delta Live Tables, right? And it's quite popular. People use it for basically, ETL, a lot of ETL use cases as well as ingestion use cases. So what is the, I think the key here and the popularity for like something like Delta Live Tables is that a lot of it is the operational side of things. What people find really difficult in streaming is operations, right? SQL is just telling, the system, I want this result, right? Doesn't really say how you're supposed to run it, where you're supposed to run it, or how much I want to, spend running this thing, right? So with like a product like DLT, this allows the user to have that experience, that white glove experience. They run their SQL, things like auto scaling, where to run it, CI/CD. All of that is more or less taken, care for you, and that really allows the user to invest in the business logic instead of figuring out the stuff that arguably the user is probably not going to be an expert at to begin with, and it's going to be hard for them to navigate that. So those are stories that, or things that really resonate, especially with our users, potential users, is making it, easy to run.
Gotcha. It sounds like Databricks is approach is more kind of leaning towards kind of integration as part of Delta Lake, and then more focusing kind of ETL perspective rather than a general streaming SQL engine there.
Yeah, and another thing I think is while we talk about Flink and streaming, a lot of the conversation is around latency, right? But honestly, for the majority of the customers we talk to, it's not necessarily latency is the top in their mind, right? It's really cost. It's how little of money can we spend on this thing, right? We don't really care. It's okay if we get our results minutes, tens of minutes, even hours, but we only want to spend this much money on basically streaming, right? How do we basically, what is our approach to basically solve this problem of cost, right? And that's something that we also work on, on the streaming team at Databricks, is not only are we trying to lower the latency, but allow the user to really decide, are you going to optimize or prioritize cost, or do you want to prioritize latency, right? So those are kind of two basically kind of knobs that the user can choose.
Okay, makes sense. So like for Time Plus and Writing Wave, you guys kind of decided choosing a different route. It's not relying on either Flink SQL or try to kind of building on top of Flink to extend that. What is the kind of consideration behind that as why you decide to kind of choosing a different route to building a kind of streaming SQL from scratch?
Okay, so a few months ago, I wrote a blog called "Flink is the new golden standard in stream processing." After reading a blog, I was quite curious for why they say this. Well, because Postgres is essentially the real golden standard in the database world, right? But in data engineering world. So we don't really follow that, and we don't really follow anything like a big data SQL. We just follow, Postgres SQL. We believe that, okay, so no matter whether you have already used a Flink, Spark, or whatever, right? You probably know how to use Postgres. That's probably the first system that people will use if you come from, let's say, a computer science or data engineering background, right? So we believe that, okay, we actually bring the stream processing capability to the Postgres ecosystem. That's pretty important. Because, well, look, Postgres is a huge success, and nobody can deny that. And it's actually way more popular than any other systems in the world. And for Postgres, well, it has a super solid ecosystem. And people using Rising Wave, and they can directly connect to like dbeaver, like it can directly connect to all kinds of these dbt, right? And can also connect to all kinds of any system that can connect to database to Postgres. That's essentially why we decide to go, embrace the Postgres ecosystem instead of like the Flink SQL ecosystem or big data SQL ecosystem. That's pretty important for us. Yeah.
Thank you. Actually, we didn't share that part, but Jerry and I actually in the same team in Splunk work a lot on Flink, right? And so we love Flink, and Flink is awesome for sure. And I guess many of you as a developer really enjoy those complex, sophisticated systems. And if you learn it, you master it, you'll be better than others, it's really a sense of achievement. So we don't deny that. But on the other hand, that is streaming or like stateful processing is a lot of details. It's more like magic. But right now I start working on some video stuff because I have to do some video editing. So just like this as like video effect creation, right? So today you have to using super fancy software from Hollywood, from Blackmagic to create those visual effects. But slowly people start using TikTok, using Snapchat to create, I'm not saying cheap, but okay visual effect, using phone, using that in the laptop within a few minutes. And eventually more and more people just can create content by themselves without asking a professor or a professional person to work in that. So that's the idea. We try to make this data streaming much easier, not just like this big company, Apple, Uber. I mean, every small company as small as like 3%, 5%, they can focus more on the data logic, not really set up a Kubernetes cluster, Flink jobs, all those stuff, and learning all the details. So we think Flink is quite okay. Actually, in my last talk in current, I use espresso machine as a metaphor for Flink. It's super nice, but you need a lot of tuning, it's very expensive. But people also need something cheaper, easier to set up. And that's the reason why we try to build something easier. Ideally, for example, in our case, it's a single binary. So we combine ClearHouse as the OLAP system, but we build a C++ version of streaming processor, something like Flink-like, but it's not Flink for sure. So you can essentially just send any data to the database, then you can run either batch query or streaming query. But we try to leverage the similar concept because it's very important for different tools using the similar concept like tuple window, hopping windows. I noticed some products such as say QuestDB. It's also a kind of tensor database, but they invent a lot of other keyword like alignment. I think that's maybe too much. If we can have a common language, then people can easily move from one vendor to the other vendor, but can easily implement their streaming logic. Yep.
Cool. Thank you. Go ahead.
One quick thing. I think like CJ, you mentioned one of the things that Delta Live Tables was for the Delta ecosystem.
Yeah.
Actually, that's not entirely true.
Okay.
It's I know the name is a bit confusing because it's called Delta Live Tables. I mean, I was not responsible for naming it, but in reality, it is full-blown streaming SQL. The sources and sinks does not necessarily have to be Delta table. It can be Kafka, it can be Kinesis. Like we support all of those things. Like it is like you can use it as full-blown, streaming SQL. Just to clarify.
Do you support Snowflake?
Sorry?
Do you support Snowflake?
That's a heated question.
Dressing from past people
Depends if customers pay, of course. I think I agree that Flink is becoming a gold standard of stream processing, and I agree with the points that you mentioned that it's complex. It's not easy to operate Flink, and that's one of the limitations that I would say have been there for a long time for adopting Flink. And I think there's quite a few companies that are putting the effort, including Delta Stream, that take away that complexity, but they still bring that power and the maturity that Flink has to broader mass. So I totally agree on the complexity part. I also think that one other reason that Flink is becoming more and more popular, it's very similar to Spark. It's community. If you look at the community that Flink has, if you look at the amount of contribution that a project like Flink has, it kind of like takes away a lot of burden of like doing everything yourself and relying on that community. And it doesn't mean that you just use it. You can contribute that to community and kind of like help the community grow and become more and more mature. So I think that is another factor that a lot of people don't see it, but in reality, when you build something, when you have a problem to solve, for instance, in the Flink space, there's a lot of folks that they can help you. There's a lot of support there that usually, if you build something from scratch, it takes time to build that community. It takes longer time, it takes a lot of effort. And for a company like us that started a couple of years ago, we didn't have the resources to build the community from scratch, and therefore we adopted Flink community or became part of the Flink community too.
Gotcha. It sounds like there's a common kind of a consensus here is that Flink is a powerful tool, but like managing Flink or writing Flink job is complicated, and that's why I think a lot of people talking about streaming SQL here. That is because you are using a more simple language that is able to describe the job that is that is able to kind of do the exactly same thing as you kind of writing a Flink job. And as kind of Jerry mentioned about kind of DOT is like the more focusing on the ETL transformation perspective. Probably the last question will probably get given to Nung is that in Pulsar functions that you work on the project called PF SQL, although it calls SQL, but it doesn't actually a SQL. It's more like a filtering type of language. And what's your take about the PF SQL?
Okay, yeah, thank you, CJ. So the motivation for us to building such kind of tool is solely like trying to make our user or Pulsar developers' life easier. So that's the thing. We found that there are a lot of like streaming use cases, but a majority of them, or many of them, are actually very trivial, I would say, including like filtering, including like routing and some kind of data transformation to do some kind of data cleaning and preparation for the next stage. For these kind of jobs, they're trivial, but they require a lot of like, the number of them may be like large. So we have customers like, they have like hundreds of these kind of jobs. In this case, like, do we really want to like, want our users to introduce another system like Flink or purchase some kind of another vendor for purchase some kind of managed Flink service to increase their cost? Or like, can we do something for them? That's the question we ask ourselves. And given that we already have the foundation of the Pulsar functions, we feel like we can build up some kind of dialect on top of that to let our user, also let the Pulsar users and our customers to deal with these like trivial streaming cases in a super easy way without worrying about like what's the APIs I want to use and how can I manage all those jobs, what are the, or do I need to like even talk to another like vendors. So we want to provide everything trivial in a simple way and seamlessly integrated with Pulsar. So that's our like perspective. If you're already using Pulsar, using Stream Native product, you will be able to harness those cases without any worry. Yeah.
Okay. So it sounds like there's a common pattern here. Is no matter like what computing engines that you're doing, essentially is like writing your own code, writing your own function, writing your own job. Sometimes can be difficult, and that's where using SQL, streaming SQL, is a solution. I definitely have a lot of questions I want to ask, but like materialized view, cost, what the kind of the details there. And we probably also have a happy hour that is going to happen soon. I'll probably just use the rest of the time to see if audience have any questions. It's time to ask these experts the questions there. Who want to kind of be...
Question on TF SQL. So that looks interesting to me because we use Pulsar, and the prospect of using something like a frame is like a step above in terms of effort. So it looks like a good introduction to doing streaming SQL. The question I have is how ready is this feature and how scalable is it?
So in terms of readiness, we're currently next Monday, this feature will be turned on our like cloud console. So it's up in a public preview stage. You will be able to access the feature and playing with it. In terms of scalability, it's actually built on top of Pulsar functions. So since we have built these like serverless functions in the Stream Native cloud, it's I will say it's really very scalable. So that's my take. Yeah, but I do want to mention, I don't want to like cheat on you and trick you into the product. I do want to mention that currently the use cases we're supporting is like filtering, routing, and simple transformations, and some like system provided built-in functions. But we believe even though with this like smaller set of functionality, it can already like make our developers' life easier. Yeah.
Cool. Any other questions? Okay. Sounds like everyone is shy and quiet. You guys can grab those kind of experts after this session. I'll probably just close this with a question is that maybe everyone just talk a little bit, what's your insight about what is the direction of streaming SQL, what kind of innovations that you guys are making, and what is the recommendation to the audience who is looking into adopting streaming SQL?
Thank you. Again,
engineer order.
Yeah, thanks. I'm making sure. So it's very important to get your hands dirty, right? So no matter whether you are familiar with Flink or familiar with Pulsar or whatever, so try to find a use case in your project or even not really production level, but try get your hands dirty. For example, many of our solutions either have a cloud version or open source Docker image. It's very easy to connect to your Pulsar, connect to your Kafka, and run a very simple select star to get the data to somewhere. If the SQL engine support join, that'll be great. So right now, it might only take you maybe 5-10 minutes to set up the first thing. So get your hands dirty. I personally joined a group called CQ Standard, but it's not really in a very good result. So people from TimePass, from Materialize, from Oracle, Snowflake, we try to extend the keyword and syntax of CQ to add more streaming semantics. We took effort for at least 1 year, but going nowhere. It's very difficult to come to a common language keyword. So I don't really think that will be coming very soon. But on the other hand, that is people really see a lot of similarity between different streaming systems. As I mentioned, those watermark, those window, really is common language. So you will not feel very different moving from one system to the other system. So my only suggestion that is get your hands dirty, try some open source tools, try the cloud version, and stop building your data processing logic using Java code. You can have a way easier way to maintain your logic using SQL. And SQL, eventually we might using AI or natural language or English as SDK, but SQL right now is still the best language to describe your logic without sharing how to do it. It's just what you want to do. Yeah.
Yeah, so I think one of the challenges still with streaming SQL is when you get down to like the semantics, it is still rather difficult for a lot of people to reason about when should I materialize my output, is this, how correct are my answers at this point? There's a lot of details and a lot of streaming concepts that arguably, for a lot of people is still very, very difficult. So like maybe, sure, like education could be one of those things that help like move this thing along. Or maybe also like, different, I guess, different providers or different platforms, they have different ways for the user to declare something like that, right? When should I emit my results? Is it an update or are these basically complete results that I have for, very high confidence? How do I define event time? These are all things that, different platforms have different ways to define this. So it definitely is, maybe in the future, like an innovation would be some sort of standardization on how you perhaps declare these kind of things in streaming SQL, but obviously this comes with education for people to understand, when to use what, right? When to actually, go in this mode or that mode, and so on and so forth. Actually, one of the, I think, places of innovation, this is what we do at Databricks, is we notice that what makes this all easier or for users in terms of how streaming and SQL come into play is really with materialized views. People understand materialized views. It's a very well-known concept, and people can kind of reason about it reasonably well, right? So one of the things that we do is using streaming to power our materialized views as a huge cost savings to our end users. So one of the things we do have at Databricks that we're working on is called Enzyme. It's really a query optimization engine that really can automatically determine whether we can execute basically compute your materialized view in an incremental fashion, or do we have to do a full refresh, right? There are certain things in a materialized views, depending on your query, you can't incrementally compute, but there are also things that you can, right? We can talk about more details into that. So having just basically a layer to automatically determine that for you and to optimize that for you really resonates with our customers and a huge cost savings to our customers. So I think continuing down that path, there could be more innovations and more basically optimizing of cost as well as latency in terms of how we serve basically materialized views.
I think the most important factor is going to be users and customers. People who are using these products are going to be the ones that are going to be demanding simplification, demanding ease of use, and demanding getting value of that. So I think that's a very big force behind a lot of products that are trying in that direction of simplifying these things. In a bigger picture, stepping back from how we see or how I see streaming SQL evolving, I think looking at the data at rest world would be a very good indicator. You started with relational databases, then the big data era, you started with storage, and then you have different compute systems, including like Presto, Spark, and those kind of systems on top of the data at rest storage that you have, and all of them ended up adopting SQL as one of the main ways that they could manipulate and process this data. I think we should be able to see similar trend in the streaming side, and from the products that are emerging, including our product, just a shameless plug, Delta Stream, we are seeing ourselves as a relational layer on top of your streaming storage. So kind of like continuation of the things that worked in the batch world, why not use the same concepts in the streaming world and make it easier for folks to get value from it.
Thank you.
So I know that a lot of people are talking about unified streaming and batch processing, right? So I think it's not just about the capability, right? We can use the single system, right? No matter whether it's a database or it's a engine, right? To do both batch processing and the stream processing. I think it's more about the user experience. Basically, people do not need to distinguish, whether I'm doing the batch processing or I'm doing the stream processing. So yeah, and I also believe that streaming SQL is a feature. Actually, a lot of people probably, especially from the big company, right, from Uber, from LinkedIn, from other companies, probably don't like my opinion. They think that Flink SQL is not, Flink SQL is not enough, PostgreSQL is not enough. Actually, well, I think that's but let's look at for the history, right? Well, if you look at the history, long time ago we had a Hadoop, right? And then we have Spark, right? I know that Hadoop, yeah, probably I'm not sure whether it's still there. I'm not sure whether it's still kind of active, right? You have the answer, right? But for Spark, well, and you can see that, okay, I mean, they are also moving to the SQL world, right? They have the Spark, and they now have the top page from Databricks is that, okay, they're actually commercializing a Lakehouse, right? Now we also have the Snowflake, right? That's what happened. What just happened within the last 5 years in the batch world. But similarly, in the streaming world, no matter how aggressively people are trying to argue that, okay, Flink SQL is great, or it's probably Spark SQL, Spark streaming SQL, no, sorry, Spark streaming Java is great. Well, I mean, eventually, most of the use cases will be covered can be expressed using SQL, and definitely we do not. I mean, Java is still quite powerful, but definitely SQL is powerful enough to eat the most of the market. Yeah, that's my takeaway.
Thank you.
Yeah, in my humble opinion, I think the ultimate goal of streaming SQL is trying to get rid of the streaming prefix so that it becomes part of the SQL. Either some of the special syntax in the current streaming SQL become the standard in the NSI a SQL standard, or the underlying engine, processing engine, I would say, is smart enough to help users to handle those streaming data or batch data separately, so that user doesn't need to differentiate the use case whether he's trying to deal with some streaming data or it's a batch data. That also echoes kind of one of the dreams the streaming engine folks trying to achieve is unify the batch and streaming processing. So in terms of Stream Native here, so we really want to combine all these awesome features developed by the Pulsar community, like the tiered storage, the Lakehouse integration, and also with the PF SQL, so that one day the SQL is able to help users to do some not only the real-time data transformations, but also some trivial data analytics works by combining the real-time data in Pulsar and also the offloaded data, batch data in the Lakehouse systems. So that's my takeaway.
Okay, thank you. I think we all have a dream that at some point the streaming extension will be part of the SQL standard. We hope you guys can make it happen. But I think it's really hard to touch everything about streaming SQL within half an hour. I hope this is a good starting point, and you get to know these experts. And if you want to grab them after the panel, I think you all recognize the face, so you can just go directly to talk to them about the streaming SQL. And that would be all for this panel discussion. And thank you for joining me together.
Can I say something controversial? So it seems interesting, right? A lot of people nowadays, and I hear a lot of this in marketing, right? People say, oh, Flink, right? That's the de facto in stream processing. I think a lot of us here would argue, right? Why is that the case? And perhaps that's something everyone here that's choosing a stream engine should think about. One of the obvious things is, look, Flink's been around for a really long time. Has there actually been a company successful to monetize Flink and sell Flink, right? And to be honest, at Databricks, a lot of the customers we interact with, they actually want to switch from Flink for a number of reasons to actually use Spark Streaming. I'm not saying Flink, there's not a place for Flink, or use cases that Flink would be better in Spark Streaming. But I think that's something for everyone to consider, is not to just, oh, Flink is a thing, everyone's talking about it, there's a lot of marketing, I should immediately pick Flink. So I just want to get everybody thinking that when you're making that choice, it's probably not so, you should really kind of think about your use case and really go and investigate these different stream engines to see which one really is good for you.
Now that's heated now, so it's heated at the end. So
can I add one small controversial thing about that? Yes, very small. I agree. It's pretty much use case and how you want to use things. And we do have prospects that are using Spark Stream or structured streaming, and they want to move to Flink because of, again, the use case that they have. You mentioned sometimes half an hour, 15 minutes delay is not a thing. Sometimes milliseconds counts, or sometimes seconds counts. Imagine you're a service that user is interacting with you. After 5 seconds, 10 seconds, user is gone from the page or from the app. So totally agree on the use case, But I think you can see the situation both way. And I would say on companies making money, gradually you're going to see more and more of that, hopefully. Thank you very much.
Yeah, one sentence. Well, I don't really care about whether you're using Spark streaming or if you're using a Flink streaming, right? Well, Flink SQL or right? Well, we actually as a company know Flink better than the Flink guys, right? Flink guys will know a lot of things about how good Flink is. We actually have a long list about how bad Flink is. And we will definitely promote all kinds of the badness of the Flink. Yeah. Talk to us if you want to move away from Flink.
It doesn't represent the organizer's opinion, so we love Flink. So okay.
I can
Okay, go ahead.
Okay, I can add one last point is from Pulsar's perspective, we think both Spark and Flink, they are really good like data processing system. That's why we provide all the integrations from Pulsar, like the Pulsar Flink connectors and the Pulsar Spark connectors. Yeah, that's
Cool.
Next time we should start from the controversial topics and then go to
That's a good one.
And maybe Mohammed will be the last person to say. Anyway, as I mentioned in my last talk, that is, it's just like coffee. Right? Someone like espresso, someone move from espresso to latte, someone drink latte in the morning, drink decaf in the afternoon. It's okay. I mean, the problem that is, come on, you should drink coffee, you should do more data streaming, no matter which one you get started with or which one you move to. I mean, still the value is there, but we haven't get enough value from the data. That's the point. Yeah.
Cool. Yeah, this is like everyone have different tests of streaming SQL, different tests of streaming processing. We also have different tests of the drinks. So it's happy hour, and let's end the panel discussion. And thank you, everyone, and thank you for coming here. Thank you.